My project is about creating a robust dynamic camera system for designers to use. The first thing I created was a third-person camera system that had some form of collision on it that allowed the player to look wherever they wanted to and objects not get in the way of them being able to play the game. One of the ways I decided to test this was to put cubes in front of the player's camera and see how the camera would react to that, how it would move around also on a closed space, which you'll see now is how the camera acts in really close quarter spaces, and it doesn't do too bad. It has some clipping issues which may need to be sorted out, and also it kind of sometimes forces the player to be like next to the camera and is not a really nice image for the player to have on the screen. The next thing I decided to add was a transition script that allowed the player to transition from one camera to another. So that would be from third person to first person to a top-down camera, a top-down camera to on-rails camera. At the moment, that's all I've implemented. To do this, I just simply use the lerp function to lerp the camera to different game objects that I've placed in positions that I feel like represent those cameras based on the research I did. However, this isn't a perfect implementation of the cameras so far, as some of the cameras have some weird bugs and issues that I have shown throughout the video. The next step would be to finish the implementation of the on-rails camera and then to continue implementing the cutscene system and then start the optimization of the existing camera systems and making sure that they are up to standard. Here is the code that my camera uses. First, I set up the input axis that I will be using, then combine the inputs so that I can calculate the rotation of the camera. This rotation is applied to the camera. Then camera update is called in a late update to update the position of the camera so that it can follow the player's most recent movements. Next is the collision script, where it calculates the desired position of the camera and line cast to make sure that nothing is obstructing it. If it is, then the camera values get clamped, otherwise the distance gets set to the maximum distance and then the camera loops into a better position.